Hello everybody, my name is John Roberts and I am not a reporter for Fox News. Welcome to another edition of Audio 101, your handy guide to everything you never wanted to know about audio engineering but have been forced to find out. Today we're going to rectify a mistake I made in last week's video when I showed a circuit diagram of a interface, a computer interface, plugged directly into the output of an amplifier. Don't do that. Do not do that. See these little preamp knobs? When you have an interface, this is basically being the amplifier. And it's turning it into a signal which you're going to send to your computer through the USB plug here. But it occurred to me that what I had probably better do is explain this by talking about different connectors and different signal levels. Now the most common connector is XLR, which stands for Extended Line Return. And it's got three conductors you'll see, which are going to be signal positive, signal negative, and ground. And it plugs into a preamp like so. That's it. You just line up the connectors, press it in until it seats, and you're good to go. Now, XLR normally carries mic level signals, but it can also carry line level signals. Let me explain the difference. A mic level signal is one produced by a microphone. Now, if you remember, a dynamic moving coil microphone makes electrical impulses by your voice causing a little diaphragm inside to vibrate. That diaphragm is attached to a magnet which is vibrating inside a coil of wire. And that induces a voltage in the wire, which is your signal out of your microphone. Now, your signal out of that microphone is normally in the range of about 1/10 of a volt. Whereas a line level signal can be up to 1 volt. As you can see, our handy dandy SCM268 mixer has a mic line switch. That's going to control the level of the voltage being output from its output. Mic is going to be about 1/10 of a volt, and line is going to be up to about 1 volt. And that's important because you don't want to put a line level signal into a preamp, because you will burn up the preamp. Now, if you do want to transfer a line level signal, say out of your mixer, you have a mixer that only makes line out, you want to transfer that into your interface. How do you do that? Well, you don't want to put it into the preamp. So what you do is you get the output of your mixer out on a 1/4" plug. Now this one is important to notice, is tip, ring, and sleeve. TRS for short. There's the tip, there's the ring, there's the sleeve, and if you look carefully, you can see there's a little plastic band that insulates each conductor from each other. That gives you your balanced signal. And instead of plugging into the preamp, it's the same port because it's a combi plug, but it goes right in the middle. And you press that in all the way until it seats. If you still see metal showing from the plug, it's not all the way in, and you won't get signal transfer. So that's how you do it if you want to do a line in. Now it's important to notice there's a difference between a tip, ring, sleeve, which is a balanced signal, and a tip sleeve, which is not. There's your tip, there's your sleeve. There's no ring, you'll notice. And that is an unbalanced signal. It's generally used for instrument inputs and for speaker outputs. Now the neat thing about this interface is you can put an instrument level signal in here. The difference between a line level signal and an instrument level signal is the output impedance of the source. A line level signal is going to be generally about 25 ohms, so you want a 250 ohm resistance impedance going in. You generally want the input impedance to be about 10 times the output impedance. But an instrument can be a full K ohm, 1000 ohms of impedance. So you'll notice there's this little switch here, says line and instrument, and you kick that over to instrument, and now that is a high impedance, 10,000 ohms input impedance. So you can plug your instrument right in and you'll hear it. If you misset your impedance, it's either going to sound weird or you're not going to hear anything. So if you're, for example, plugging in an electric guitar, you want to make sure that you've switched over to a high Z or high impedance input. One other important distinction between TRS 1/4" plugs and XLR is that a TRS plug at both ends is the same. So you can plug it in either way. But an XLR has a male end and a female end. Now, generally speaking, you want to plug the female end into the source and the male end into the load. In other words, this would be your microphone, this would be your mixer. This could be your mixer output, this is to your powered speaker. No points for guessing why they're called male and female. Technicians used to be pretty much all guys. There is one type of tip ring sleeve connector you may be more familiar with, and that is your 3.5 millimeter connection, which is also, believe it or not, this is not a balanced connection, this is an unbalanced connection, because this is stereo. So this is carrying the ground between your headphones and your source, plus the left and right audio channels. So that's stereo, that's not balanced. Now the reason that you should not plug the output of an amplifier into your preamp is because that preamp wants about a 1/10 volt signal, a microphone. The output of an amplifier can be anywhere up to 70 volts. So you want to be careful with speaker outputs, especially high energy speaker outputs such as an installation power amplifiers. But you also never want to plug the output of an amplifier into the input of a preamp or an interface. That's really all I have for you today. Just a little brief explanation of different signal levels, your microphone level, your line level, and your amplifier output level, and different types of audio connectors. You've got two balanced connectors, your tip, ring, and sleeve, and your XLR, and you've got one unbalanced connector, tip sleeve. Now I know I said I'd talk about stereo mixers, but I've got a few things going on this weekend, which means I have to do a bounce. But I figured I'd put some content up real quick just to help you understand those different signals and connectors. And thanks for coming in and checking that out. If you have questions about signals and connections, leave a comment below. Oh, and don't forget to like the video, subscribe to the channel, ring the bell so you get notifications, all that good stuff. Thanks for tuning in, and I'll see you on the flip-flop. Bye!